We're going to start off our presentation with a word from our professor, Dr. Arif Malik.
This summer I was really happy to host 5 high school students in our Computational Research and Advanced Manufacturing Lab. This is part of the CAST STEM Bridge program, and the students came to UTDallas to essentially study and learn how to perform research in relation to selective laser melting or additive manufacturing of metals.
And now we're going to talk about some of the programs we used in this camp.
SolidWorks, a 3D designing and modeling program, was the first program we learned in this camp. This gave us insight into CAD and CAM. Starting from basic designs, we then gained knowledge on a diverse assortment of tools and techniques utilized by engineers to model various machine parts and assemblies. Applying our familiarity, we designed an 18-tooth Spur gear, which was then used to simulate additive manufacturing.
MATLAB, a powerful scripting language with many applications. We applied MATLAB to calculate the centroids for large sets of nodes and elements, enabling us to simulate 3D printing in abacus. At the start, we struggled with the software, but with time and effort, we learned how to code more complex programs. In total, we made more than 25 scripts with MATLAB, including simple top and sorting numbers and more complicated scripts, like the aforementioned centroid script.
Abacus is a program primarily utilized to run simulations on various types of models. In our case, we ran tests on the gear we modeled previously. After importing the gear into Abacus, we ran 2 simulations. In the first one, we simulated the 3D printing of the gear. In the second, we ran 2 copies of the gear against each other. Additionally, we defined the material properties of the steel we used, AISI 316L carbon steel. This would allow us to realistically depict the residual stresses after additive manufacturing and the damage that would occur in our simulations.
During the last week of camp, we received a tour of the Emerson facility in McKinney. We learned about different types of additive manufacturing of plastics as well as metals, including binder jetting and selected laser melting or SLM. During the tour, we visited the flow test lab, environmental lab, material lab, and SLM manufacturing machine lab.
From what we learned, while still in its early phases, SLM and other forms of additive manufacturing may prove to be a relatively economical and time-efficient replacement for conventional manufacturing techniques. Our results show that additive manufacturing results in residual stresses in the material, which in most cases make the part stronger. Our test component, an 18-tooth Spur gear, proved to be more resilient than its conventionally manufactured counterpart, proving that additively manufactured components may one day replace their existing analogs.
And so hopefully this was a really valuable experience for them. I know from the point of view of my graduate students, being able to work with them over the summer, graduate students really enjoyed it, and they enjoyed the time that they spent teaching and learning together with our high school students. So really glad that they joined the lab.